Welcome to Module 4. So this module is just a continuation of hypothesis testing from last module. So last module was the introduction to the hypothesis testing. So in case you're confused with Module 3, I recommend you go back and review Module 3, because if you were unclear about Module 3, Module 4 will be as confusing at the same time. So I recommend you go back, in case you're confused about hypothesis testing, the basics of it, I recommend you go back and review Module 3, and then tackle Module 4. So in the last module, I wasn't explicit with this, but we were doing hypothesis testing on just one sample. So to continue on that, this module will look at two samples. So instead of one sample, we're going to look at two samples this week, and we'll do similar things. So last week we looked at the proportion, the mean, when we know sigma and when we don't know sigma, and then the standard deviation or the variance. So we're going to do the same thing this week. We are going to look at two proportions, the two means, known sigma, unknown sigma, and then the standard deviation and or variances. And this week we launch into the differences between independent samples and then dependent samples, which I'll have you read in my spreadsheet. So I'm going to focus on the calculations today using these topics here. If you read through the lecture notes, which I still recommend you do, you'll notice there are a lot of errors, which I can't really do much. So for example, there's like a missing picture, like missing numbers and such, like here. So if you're going through the lecture notes and you see something that's a little bit weird, you can look at my spreadsheet, which will fill in the missing pieces. So if you follow along the lecture notes with my spreadsheet, you'll see the missing pieces. So just FYI. All right, so let's look at the testing of the claim about two population proportions, which is in my spreadsheet. Oh, so before I go on, there's one thing you need to do. So if you're in 2010, 2013, 2016, you should see, if you go to the data tab, oh, it's not here, but you should see a data analysis tab here, so which I don't have it with me, so I'm going to show you how to add that in. So do this part before you continue this module. Go to File, so this is 2013, and 2016 should be similar. So go to File, Options, and Add-ins, and then Add-ins down here, and click Go. And click on this analysis toolpack if it's not checked. Press OK. And now if you go to the tab, Data tab, you should see the data analysis here. So if you don't have that, add that in by doing what I just did. All right, so hypothesis testing. The general procedures are the same. The rules are the same. Set up null hypothesis, alternative hypothesis, the alpha, calculate the test statistic, T, Z, or chi-squared, and make a decision as to do you reject the null hypothesis or not. As you go through the calculations, the formulas, you see the formulas get rather complicated really fast, like for example here. So in case you're not doing the calculations in Excel, I'm suggesting that this is the time that you learned how to do calculations in Excel, because if you try to do this by hand, you'll not be able to finish on time, and then most likely you will make an error, which you get a wrong test statistic, and then you probably know by now that once you get the test statistic like Z incorrect, the whole thing is wrong. So I still strongly recommend you use my spreadsheet to do calculations this week. All right, so let's look at an example for comparing two proportions. All righty. So here's an example. In a study of treatments of very painful cluster headaches, 150 patients were treated with oxygen, and then 148 other patients were given a placebo consisting of ordinary air. Among the 150 patients in the oxygen treatment group, 116 were free from headaches 15 minutes after the treatment. Among the 148 patients given the placebo, 29 were free from the headaches after 15 minutes. Use a significant 0.01 significance level to test the claim about the oxygen, that the oxygen treatment is effective. So the claim is with oxygen, it will treat the headaches. So you see there are two groups of samples. One is consisting of 150 patients who were given the oxygen, and a separate group which consists of 148 people who were given ordinary air. So I have a list here. So out of 116, out of 150, 116 were free of headache, and then similar for placebo. All right. So we're saying that the implicit claim is that the oxygen proportion should be bigger than the ordinary air proportion. So if you compare the sample 1 and sample 2, the proportion in sample 1 should be bigger because we're saying that oxygen will help with the headache, so more people will be treated, will be free of a headache. So just randomly, I selected first group to be proportion 1, and then second group to be proportion 2. So the P1 is oxygen, P2 is ordinary air. So if that's the case, I set up so that the proportion 1 will be bigger than proportion 2. It's not explicit here, but you have to kind of infer that from reading the problem. And again, I know this is a hypothesis testing problem because it says test the claim, and then alpha is going to be 0.01. So I'm just going to use these numbers here. So your job in your quizzes or assignments is that you put the right numbers here. Okay? The rest will calculate. So make sure you have these numbers correctly. So then to calculate the proportion 1, you have to have these two numbers. To calculate the proportion 2, you have to calculate these two numbers. And you know how to calculate the proportion because it's x1 divided by n. So if you do so, you will calculate the P1 hat, P2 hat, Q1 hat, and Q2 hat. Okay, so that's how you calculate these numbers. Sometimes you're giving these numbers instead. If that's the case, what you have to do is work backwards to fill in the missing piece, which I'll show it to you in a little bit. So you kind of have to figure out which way you got to go. Typically, you'll be given these numbers to calculate this, but sometimes you're given this. If that's the case, you have to work backwards so that you have the right numbers to get these numbers correctly. All right, so once you get these numbers correct, you will have the rest will be a piece of cake. This P bar, so instead of P hat, now we have a P bar and Q bar. P bar is, the formula is x1 plus x2, the whole thing divided by n1 plus n2. x1 being this, n1 being this, x2, n2. Same thing for Q bar is going to be 1 minus P bar, so this is what this is doing. Okay. This P bar is a new letter variable we're going to be learning, which sometimes is called the pool sample proportion. So if you're asked for the pool sample proportion, it's asking for P bar. Okay. And hopefully by now you know that you have to calculate the test statistic, which the formula is this. Again, it's rather complicated, but this cell reproduces this. We know P1 hat, P2 hat, P bar, Q bar, N1, P bar, Q bar, N2 from above here. The only thing we don't know is P1 and P2, but we are going to assume that P1 minus, there's no difference between proportion 1 and proportion 2, so you can assume that to be 0. And that's why I have it 0 here. Okay. So for this class, just assume it's 0. Once you do that, this cell will calculate the p-value. Okay. So for this example, it's doing the right tail answer because the alternative was higher here. So now from last week, you know that if it's proportion 1 is bigger than proportion 2, if it's a greater than sign here, then this cell is calculating the right tail value. So if it is left tail, for example, if this was less than here, then just switch this to cell look like this to get the left tail. So this section will calculate one tail, either left tail or right tail, for claim about 2 proportions. And the only thing you got to change is down here. Now, that's the p-value method if you're doing that. The other method you learned last week was the confidence interval method. So this section down here will do the confidence interval method. Okay. Here's what it gets confusing. It says 0.01, so you would think the confidence level will be 99% for the confidence interval method. But the book says to refer to table A1, which here, it says that if it's you doing one tail with the alpha of 0.01, you use the confidence level of 98% for the confidence interval method. That's why I have 98% here. That's why I'm looking at the 98%. Okay? So if it's 98%, you know how to calculate that this is critical value from module 2. So use 98% for, it's going to be 2.33. That's why I have 2.33 here. And that will in turn calculate the margin of error. And we're doing this because you need a margin of error to calculate the confidence interval. So this is going to be the lower end. This is going to be the upper end. So this is the confidence interval that's reproduced in this section right here. It's doing P1 bar minus P1 or P2 bar minus E for the lower end, and P1 bar or P1 hat minus P2 hat plus E on this side. So if you're doing the confidence interval method or the critical value method, get the correct critical value here and refer to table A1, which is going to be in modular in a spreadsheet from last week and then this week down here. So make sure you get this correctly. Once you do so, you can make your decision. So let's say if you use a p-value method, which says since the p-value is practically 0, it's less than 0.01, so that means we reject the null hypothesis. So that in turn means that we're saying the oxygen treatment has some is effective. Okay? So that means we're rejecting the fact that the oxygen treatment has no effect. We're going with the alternative. That means one way to say is that the oxygen treatment seems to work. Okay? So you can use p-value method or the critical value method. The critical value method says it's in positive area. It doesn't contain the value of 0. If the interval does contain the value of 0, that implies that there's no difference. But you can see that even at low end and high end, the difference is positive, meaning that P1 is bigger than P. That implies P1 is bigger than P2. And then P1 was the oxygen group compared to the ordinary air group. So that means, again, it implies that the oxygen treatment does have some effect, good effect. And typically, the confidence interval method and the p-value method or any of the methods should yield the same conclusion. In this case, the oxygen treatment is effective. But just a FYI, in case of the proportions, the confidence interval method can give you a different conclusion. So just be aware of that. I don't think we will see that, but just FYI in the future, if you do all 3 methods and you see the confidence interval method gives you a different conclusion, that could happen. Okay? So that's the one tail and then the confidence interval method. If you're doing 2 tail, here's how you do it. Okay, here's an example. In a random sample of 300 people aged 20 to 24, 21% were smokers. In the random sample of 250 people, age 25 to 29, the 12 were smokers. Test the claim that the proportion of smokers in two age groups is the same. Use a significance level of 0.1, and then show all the steps in the calculations. Okay. So we have two samples, one with 300 people, age 20 to 24, of which the 21%, the proportion were smokers. In a separate one, out of 250 people who are ages 20 to 29, the 12% were smokers. Okay. Significance level is 0.1, so that means alpha is 0.1. So if I summarize this, here's what it says. Okay. Proportion 1 is the same as proportion 2, and the alternative would be that the proportion 1 is not the same as proportion 2 because it doesn't say anything about greater or less than, it just says proportions are the same. Implies that they're either the same or not the same. So that makes it two-tailed. Proportion 1 is 21%, proportion 2 is 12%. Okay? So if I summarize the data, 20 to 24, there are 300 people, 25 to 29, there are 250 people, but these are given to us. Okay? In order for the calculations to work, we need to calculate x1 and x2. So in order to do so, just simple algebra, to calculate x1, you multiply p1 or p1 hat multiplied by the n1 to get this. And then you will get x2 if you multiply p2 hat multiplied by n2. That's how I get 30. Okay? So if you work backwards to calculate x1 and x2, you might get x1, x to be some unnatural number, like, for example, 63.2 or something like that. You might get a decimal. And you might be tempted to make it 63. I don't do that. If x1 and x2 seem to be unnatural numbers, but p1 and p2 are exact matches to what's given to you, leave x1 and x2 alone and just continue with the calculations. We want the p1 hat, p2 to be precise rather than the x1 and x2. So even if these numbers don't make practical sense, leave them as is. If you do that, the spreadsheet will calculate the correct p bar and q bar and then z and then everything else. All right, so now I'm going to be looking at, so this is two-tailed, 90%. Okay, so go back here. I see that for the 90%, the z is 1.645, so I'm going to use that. Oops. Oh, sorry. That's the critical value. This is the test statistic, and we're going to compare this to this. So 2.8 is bigger than 1.645, so we reject the null hypothesis. Okay, that's the same rule as from last week. This is outside the interval, so we're going to reject the null hypothesis. Okay? So there's what's the conclusion? The conclusion is that there's sufficient evidence to support the conclusion that the proportion of smokers in the age groups, in the two age groups, is not the same. Okay? We're rejecting this and going with the alternative. So we know they're not the same. How different, we don't know, but we know they're different. All right, so that's how you do proportion problems. Let's go to independent samples. Okay. Here's independent samples. Here's the dependent samples. Basically, dependent samples are paired. Okay. And for this tab, we're looking at independent samples, looking at the means, and we don't know sigma 1 and sigma 2. We don't know the sigmas, and we assume they're not equal. And we have this particular description because this is the most likely scenario you're going to run into in the field, in the real world. We typically don't know sigma, and we typically can assume that they cannot be the same. It's very rare that the standard deviation are the same. So in this scenario, most likely scenario, how do we do problems? Let's look at example. Researchers conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. Other subjects with a blue background were given the same task. Let's see if the color makes any difference in terms of creativity. Okay. Oops. I guess there's a little more. Researchers make the claim that the blue enhances performance on the creative task. Test the claim using a 0.01 significance level. Okay. So that implies that the proportion of blue should be larger than the proportion of red, and alpha is going to be 0.01. Okay, so just randomly, I just picked the red group to be group 1, and X2 to be, or the second group to be blue. Okay, so that's the case, then this was given to us. Let's assume this was given to us. Okay. Then there's 35 people, and the creativity score was 3.39 for red. Standard deviation was 0.97. And for the blue, there's 36 people in that group, and the mean score was 3.97, and then the standard deviation was 0.63. So if we assume this, then mu1 will be, the means are the same, mu1 and equal to mu2. And since we're assuming red to be group 1, we're going to assume that the mean of 1 will be less than mean of 2. Okay, so then we are thinking the creativity score will be less for red compared to the score of blue. All right, so then we're going to be using T. And if it's T, now you know it uses degrees of freedom. And so then which one do we use? And the answer is we pick the smaller of the ends, so 35 versus 36, so in this case 35, and subtract 1, so 34. So that's how I know that degrees of freedom is 34. And then we'll calculate the test statistic T, which the formula is this. Again, I highly recommend you use my spreadsheet. Just punch in the right numbers here to get this number here, and then this to get this right number here. Okay. Again, we're assuming the difference between mu1 and mu2 to be 0, so that's why you see a 0 here. All right. So now this is one tail. So confidence level is going to be, what is it? 0.98, okay? Because it's one tail and the significance level is 0.01. It's not going to be 0.99. It's going to be 0.98 here. So make sure you get that right. And if you do that, critical value will be calculated, okay? And the p-value will be calculated. And so this is the critical value, this is the p-value, and this is the confidence interval. You get that from calculating the E, which this cell reproduces all this calculation. Okay? And you have the confidence interval method. So now you have three choices. You can do critical value method, p-value method, or a confidence interval method. Okay? Let's look at all three. We know that test statistic is, where did I do it? This. Critical value is this. So compare these two numbers, and you see that the test statistic is smaller, or greater depending on what you see. So, but this is smaller than the critical value. So if the test statistic is outside the interval, again, you reject the null hypothesis. So that's the critical value method. If you look at the p-value, which is 0.00265, that is certainly less than 0.01. So again, you reject the null hypothesis. That's the p-value method. And if you look at the confidence interval, you see that the 0, assuming the difference of mu1 and mu2 is 0, this confidence interval does not contain the value of 0. It seems that the mu2 is bigger than mu1 because if mu2 is bigger than mu1, the difference will be a negative. So this implies that mu2 is bigger than mu1. So again, you reject the null hypothesis. Okay? So pick in any method you pick, which you're allowed to pick unless the problem specifically says to use one method. You pick whatever method you like, and in any case, you see that there's sufficient evidence to support the claim that the blue color does enhance the performance on the creative task. Okay? So that is a lot I covered in the little rambling I just did. So if you didn't quite get all that, I recommend you go back and review what I just did. But the end result is that regardless of which method you pick, the conclusion is the same, which says the blue does seem to help with creativity, at least in this problem. Okay, so if you have any questions, let me know. Okay, that's a lot. So the good news is, let's move on to when we do know sigma, and either we know the sigmas to be equal, or we know sigma 1 and sigma 2. Okay. Again, that's very rare, so we're not going to cover it. We're not going to do actual calculations. But if you ever do need to do it, here's the information on how to do it. I highly doubt you will run into this, but for completeness sake, here's what you need to know. Okay, so moving on. Now let's look at the dependent samples, pair sample. Okay. So we're going to be testing the hypotheses involving the mean of the differences of the values from two dependent populations. Okay, that's a mouthful. Basically, we're looking at dependent samples and then the mean of the differences, which requires you to learn a few more words, terminology. We're going to be using mean, so we're going to calculate t. And moreover, d represents the individual differences between the two values in a single matched pair. Mu of d is the average of the d's. Okay, so there are going to be a bunch of d's. Mu of d is just the average of that. Sorry, take it back. D bar is going to be the average of d's. Mu d is just the mean value of the differences d for the population. Okay? Typically assume this to be 0 because we assume there are no differences. So d bar is the mean or the average of all the d's we're going to calculate. And S of d is a standard deviation of the differences of d. And n, as usual, is number of pairs in a sample data. Okay, so let me show you how to calculate d, d bar, and then S of d. Let's assume you're given this information here: the height of the president and the heights of their main opponents. Okay? To calculate d, you just take the difference between this and this. Okay? To get a square, you just square it. Okay, that's shift 6. Okay, so this table will be able to handle up to 5 pairs. Okay, so if you have more, just repeat what it's in here over here. Okay, should you need to do so. So this is just an example up to 5 pairs. But if you need to do more, just extend it and just keep doing it. Okay, so again, this is the average of all these numbers. Okay? And if you have more, just include them all. Just extend this. Same thing, n is 5 pairs. So if you have more, obviously extend this more. And this is the variance, which is S of D. I included here because the lecture notes has it in there. Again, just extend this if you need to. And what we want is this, which is square root of this, or the standard deviation of all these numbers. Either way, you get this. So S of D is about 11.4 centimeters. Okay, so that's how you do the D bar and S standard deviation of D. I'm just reproducing what's in the lecture notes. You can also use var.s or stdev.s for these calculations. Okay? Or here, average function, whatever you're comfortable with. The test statistic formula is this, so we'll do this later on. And the confidence interval is reproduced by this. There's an E, and the E is calculated by this formula. Okay? So hopefully nothing's new to you, just different formulas, but we're calculating the exact same things. All right, so let's look at the real continuation of the example. Use a sample data below for a significance level of 0.01 to test a claim that for population of heights of presidents and their main opponents, the differences have a mean greater than 0. So we're making the claim that the presidents tend to be taller than their opponents. Is that so? So let's take a look. Okay. You'll be typically given this data up here, these 2 rows. So you have to do the bottom 2 rows, which we just already did. Okay. So then what's the null hypothesis and alternative hypothesis? We're assuming that the difference is 0, so there's no difference between the presidents and opponents. And the alternative is saying, no, we're thinking the presidents are taller than their opponents, so the difference would be positive if the presidents are taller. Well, let's take a look. Okay, so this is assumed to be 0. You know how to calculate this. Use the average. There are 5 pairs. This is the variance, and this is the standard deviation. So what we already had up here. The new thing is we have to calculate the test statistic, which this cell is using numbers here, which is the reproduction of this. Okay. Another way to do this is as follows. Use the data analysis button that we already created. Click on it, and it's going to be t-test paired 2 sample for means. Click OK, and then this pops up. So what's your variable range 1? It's going to be this. What's your variable 2 range? This. And notice that I included the label here, so I'm going to click on here. Should be 0. I'm going to create a new worksheet. Okay, and this pops up. Okay, so I have a better version of this over here. So this is just a reproduction. Notice that you see the test statistic is going to be 0.628. Okay, which you see here. And other things you see is that this is going to be the p-value method, a p-value here, and then the critical value. So if you have Excel calculate things, the method I just showed it to you will calculate all 3 numbers for you right away. So either way, you can use a formula or the method I just showed it to you to calculate the test statistic and p-value method, or p-value. So we see that the critical value is 2.13. You compare that to the test statistic. You see that the test statistic is smaller. Okay. So then there's no sufficient evidence to support the claim that the population of heights of a president and their opponent, main opponent, the differences have a mean greater than 0. So we're rejecting we cannot reject the null. Okay. Either the p-value method, which is greater than the alpha given to you, which was, what was it? 0.05. Okay. And the critical value method also says you cannot reject the null hypothesis. So then in the layman's term, that means presidents do not appear to be taller than their opponents. Okay. So I'm using this, and critical value method. Now, this was a right tail example. Okay. Because it's greater than. If it's a less than here, or left tail example, make the change, to look like this, to get the left tail p-value. Okay. All right. So that's how you do dependent sample for critical value method and then the p-value method. Okay. So how do we do the confidence level, confidence interval method? Well, again, we have to use a table. Okay. And we're doing one tail with 0.05, so 90. Confidence level is 90%. That's why I have 90% here. Once you have this, this will calculate critical value, margin of error, and then the confidence interval, which in this case, the confidence interval does contain 0. That implies a difference could be, and it most likely is 0. So again, it matches the conclusion we had above here, which is that the presidents are not necessarily taller than the opponents. Okay. So take a moment to understand all the methods. They will yield the same conclusion. And this is for the dependent samples. All right, so now we cover the proportions, the mean, known sigma, unknown sigma, and the means for the dependent samples. So the last one we got to cover is independent samples with sigma 1 and sigma 2 unknown and not assumed to be equal. But in this case, we're going to be looking at the standard deviation. Okay? If that's the case, you come to this tab. So same situation, except that as the previous creativity example. But now we're going to test the claim that those tested with the red background have a creativity scores with the standard deviation equal to the standard deviation of those tested with the blue background. Use a 0.01 or 0.05 significance level. So we're going to be looking at standard deviation, not the mean. So if that's the case, you come to this tab, F test. Okay. In doing so, we're going to introduce a new test statistic, which is F. Okay. F comes from comparing two variances, S12 and then S2 squared. Okay. So if you're comparing two samples independent, the standard deviations, you have to use F. And Excel can handle that. In order to do so, there's one thing you need to do is that to make sure the first group, whatever that is, has the higher standard deviation. in order for the calculations to work in an Excel. Because Excel assumes, it doesn't matter if you're doing manual calculations, but in Excel assumes that the S1 is bigger than S2. So whatever it is, make the S1 or first group to be the one with the higher S. Okay. So if you do so, all these will calculate for your all these will calculate the correct values. Okay. So if you're following the lecture notes, I reproduced the picture here. Okay. So F is similar to chi-square, where it has a left tail and a right tail, and it's not symmetrical. Okay. So if you do the critical value method, which will have two of them, left side and then the right side. So this is the left side and this is the right side. The lecture notes, the lecture doesn't include the left side, so I added it in here. Okay. But F has right side critical value and the left side critical value. In this case, we're going to be using the right side critical value because the test statistic is onto the right. So critical value is here. The test statistic is over here, which is in the rejection region. So hopefully you know now that we're going to be rejecting the null hypothesis. Okay. Confidence level is 95% because we're doing a two-tail test according to this. Okay. So with that, we have left critical value, right critical value, and p-value method. Okay. So regardless of which method you pick, there's sufficient evidence to warrant the rejection of the claim that the two standard deviations are equal. So that means we're rejecting this and going with this. That means, no, the standard deviations are not the same. Okay. How different, which one's bigger, we don't know, but we know they're different. Okay, so that's the lecture. Let's look at the assignment, which I should have downloaded already, but let's open it. Okay. I just want to make sure we have everything covered. Okay, so you can do number 1. You can do number 2, you can do number 3, and you can do number 4. Number 4, it says to use a table, but you don't have to because you're using Excel. So ignore this part if you're using Excel. Right? And you can do number 5, 6, 7, 8, 9. Okay, you can do, so now you can do the assignment. I'm not going to give you the answers this time because I'm hoping you'll be able to not only calculate them, but make sure that numbers are correct. Okay, so that's that. And quiz should be doable, which I guess I'm not going to show it to you. And let's see, course project, okay. Basically, course 4 project is that you're putting everything together. So gather my feedback. If there are corrections you're going to make corrections and put it all together as one coherent paper. Okay, just put it as one summary report. And that's what you need to do for Module 4. And I'll look at it and give you a grade. The good news is it says in Module 5 you got to do another round, but I'm going to have you skip Phase 5, so make sure you take the time to do Module 4 correctly because that'll be a last piece you're going to be doing for Module, or for the course project. Alrighty, so that should cover everything, and if you have any questions, as usual, let me know and then I'll get back to you. Okay? Have a good week.